Myself and Arun Kumar from SNS College of Technology in the Department of EC. In this video, we are going to discuss about impulse and step response analysis of first order systems. So the following things we are going to discuss in this PPT: relationship between standard test signals, Laplace transform of the test signals, time response of control systems, introduction of first order system, impulse response of first order system, test step response of first order systems, relation between the step and impulse response, analysis of simple RC circuit, and assessments. The relationship between standard test signals. So there are some lot of signals are available in control systems based on the time only. It can able to forward to the destinations, especially for step response ramp signals, parabolic signals. So in this slide, we are going to see about how the time signals has been uh, defined in this particular control systems. First one is impulse response. The impulse response has been notified by so del of t equal to a into t of 0. If it is having 0 value, then t not equal to 0. The same step response also the same formula. The step is unit step. It is having only the limited value, so that greater than or equal to 0. It is 0, then t less than 0. Then ramp signal is maximized value as 1, a into t. So the t greater than or equal to 0. So 0, t less than 0. Next one is parabolic. So maximize characteristic equations are followed by using this parabolic signals. A into t square of by 2, t greater than or equal to 0. If it is 0, then t less than 0. So like that, impulse response of the system is denoted by a. So if t equal to 0, if it is 0, then t not equal to 0. Then step response of the system is calculated by a, t greater than or equal to 0. If it is 0, t less than 0. So like that, all the ramp also calculated as a into t less than 0. So parabolic is at square by 2 t greater than 0. So these two signals are very important for calculating the control systems, because it may be available for large number of signals transmission, and moreover it can be very useful to identify the time signals in characteristics equations. First order systems. The first order systems are the systems. It can be represented by characteristics equations. Here they are taken some example of transfer function g of s equal to 10 by 3s plus 1. So here 3s s power 0, so s power 1. So normally the s value is only 1, so that it maybe comes under first order systems. So like that, it can be calculated all the values such as gain and time constants. So the next one is impulse response of first order systems. The transfer function of the system is notified by k by ts plus 1. It is ts is s power 1 is known as first order systems. Like that, impulse response of the transfer functions has been implemented through the Laplace transformations. It can be calculated by c into e power minus at. Step response of first order systems. The transfer function k divided by ts plus 1 has been notified by as 1 by s. So like that, it can be supported as c of s equal to k divided by s into ts plus 1. Next, after finalize the equation, we can take the Laplace transform as k by s minus kt into kt divided by ts plus 1. So finally, we can get c of t equal to k into 1 power 1 minus e power minus t by t. So the step response of the corresponding equations, characteristic equation, has been formed based on the gain is steady state output divided by input. So let us consider k equal to 10. Then automatically the transfer function of the t equal to 1.5. After substituting k value 10, then we can get the final answer as gain of the corresponding step response. Next one is relationship between step and impulse response. So the step and impulse response of the systems has calculated based on the differentiating equations. While differentiating the equation with respect to time, we can get the final answers. So like analysis of RC circuit. So here based on the Laplace transformation of the control system, we can calculate the resistor and capacitor value with respect to time. Initially the current and voltage value is based on the closed and open loop circuits. So here the values of the RC circuit is calculated by R into current I of t plus voltage V into V of t equal to threshold voltage of t. So like differentiating the equation, we can get differentiate of corresponding terms. We can get the final answer as RC dVt by dt plus V of t equal to V threshold of t. So the input variable is depend on the state variable V of t. Next one is the corresponding analysis of the RC circuit is based on input and output values. If it is input value is matched with the output, then the value is correlated based on the time signals. Assessment. So here they given about first order system CFT equations. So in this equation is modified based on the Laplace transform of the control systems. After modification, we can get the equation as C of t equal to 3 into e power minus 0.5 into t. So in this, the gain of the corresponding time signal is k equal to c and the time constant t equal to 2. After substituting these values, we can get the final answer as c 6 minus 6 into e power minus 0.5 t. So like that, all the values has been calculated based on the time response. Thank you.